right. So I will be talking about building a self-service access management solution with GitHub and Boundary. That's sort of a mouthful. It's nothing like having a late session on the last day of the conference, right? So I'm really pumped up for this. So during a normal workday, I prefer to have as few distractions as possible. So preferably, I have my code editor open, and I have my terminal. However, as I guess most of you are aware, this is most likely not the case, right? So you have to interact with all sorts of things during a normal workday. It could be anything from, I don't know, chat applications, or work item boards, you name it. It could be anything. And I believe that in the context of access management, this problem is often multiplied. And when I speak about access management, I mean human-to-machine access. So it could be a developer requesting access to a virtual machine or a database or something like that. And it could also be an administrator providing the access for the developer. And I argue that there is a problem of cognitive overload in the context of access management. So this cognitive overload comes in two forms. So first of all, we have a cognitive overload from portals. And when I say portals here, I basically mean anything you have to interact with in order to gain the access that you need. So it could be anything from you need to talk to the correct people using one of the two chat applications that your organization is using, because an organization can never decide on one tool. You need to read through wiki documents in order to find out how does this work. You need to sign into cloud portals to find the correct resource you're connecting to find the details about it. And you need to use secrets management systems as to what are the credentials required to connect to this instance. We also have cognitive overload from network complexity. So you often need sort of intimate knowledge about the network. So your organization might be using different cloud providers. You have your on-premises network. You have maybe some private data center somewhere. And depending on what you're trying to access, you sort of need to know how your network is configured. You might need to connect to a specific VPN to reach a resource in cloud provider A different VPN solution for cloud provider B, and so on. If you're unlucky, you also need to request a port to be opened in a specific firewall. So you're once again brought back to this first point of portals. So this is the problem I will be tackling today with my solution using GitHub and Boundary. But before I do so, let me just briefly introduce myself. This is me. My name is Mattias Fjellström, and this image was taken the day after the previous HashiConf. So fun fact is, this is the first, and it was also the last time I ever used a selfie stick. So I work as a cloud architect consultant at a company called Solidify. I'm based in Sweden, and more specifically in Gothenburg. And another fun fact for you is that Gothenburg is the only Swedish city with an English name, so it's Gothenburg, while in Swedish it's called Göteborg. I have my own blog. You can find it on mattias.engineer, and yes, that is a valid domain name. I write a lot about Terraform and other things. That's interesting to me, and hopefully to you, the reader. I recently wrote and published a book called Terraform Authoring and Operations Professional Study Guide. So this book is available on LeanPub today. And if you come and find me after this talk, I can provide this book for free for you. This is my second year as a HashiCorp ambassador. It's the first time ever I present at HashiConf, so it's quite exciting. All right, let's turn back to this problem of cognitive overload in the context of access management. So I have built a solution using GitHub and Boundary with the help of Terraform and Vault in the backend. GitHub will be sort of the front end of the solution. So a developer will be interacting with GitHub in order to request access to a specific resource, while Boundary is more of the back end of the solution. But before we look at specifics of this, I want to highlight 4 key characteristics of a good solution. So first of all, a good solution should unify access management. So no matter what type of resource you're trying to access, it should be like a single workflow. So if it's Google Cloud, if it's AWS, if it's Azure, if it's your on-premises or your Kubernetes cluster in your basement, it should be the same process. I believe the solution should allow for self-service. So a developer should be able to request access and have that access provided within certain restrictions, and I will come back to that. Solution should abstract away the network architecture, which basically means as a developer requesting access to a resource, that developer shouldn't need to know intimate details about the network and how different things are connected. It should just be transparently handled for the user. The solution should also abstract away secrets. So as a developer wanting to access a specific resource, shouldn't need to dig through different key vaults, etc., in order to find the correct credentials to connect to this instance. All right, so to illustrate what this solution looks like, we'll be following a specific organization during a normal workday. So this organization is based somewhere in the mountains of Sweden. And I know a common misconception about Sweden is that Sweden and Switzerland are sort of the same thing. And this image will not help you understand the difference. So this organization is called Umbrella Security. Umbrella Security is a cloud solution provider covering all of your security needs, basically. That's why it's an umbrella. So more specifically, we'll be following along Jane Umbrella, and she's working as a cloud security expert at this organization. All right, it's Monday morning, and Jane arrives at work. She lights a fire in her fireplace. She lights a few candles. She pours herself a large cup of coffee. So this is what a typical office in Sweden looks like. So she opens her laptop and starts reading through the emails that have arrived during the weekend. And she quickly discovers this email from her colleague, John Umbrella. And he writes, Jane, I have identified a potential security vulnerability that may affect our Linux machines. Could you run tests in our environment to see if this is a cause for concern? Best regards, John. Now, we don't know why John didn't just do this for her, but, well, she's up for the task, so she will immediately start working on this. Fortunately or unfortunately, the platform engineering team at Umbrella Security has sort of, they are starting to reach a zero trust network solution. So Jane doesn't have access to any specific instance where she can run these tests. But luckily, the platform engineers have also set up this self-service solution, so Jane is able to request access to a specific instance. So I will be showing a live demo, not a live demo, I will be showing a pre-recorded demo of this, but before I do so, I just want to go through what we will be seeing in this demo so you have a better understanding. So first of all, Jane will be requesting access to a specific resource. And I mentioned that GitHub is sort of the front end of this solution. So she will be signing into GitHub, and she will go to a specific repository. And in this repository, she will create an issue. And in this issue, she will specify what target she's trying to access, for how long she requires this access, and why she needs this access. So she submits the issue. This will trigger a GitHub Actions workflow, and this workflow will interact with Boundary to set up the required access. So what we have here is sort of an issue ops approach, where we're using issues to drive automation in our environment. In this case, it's the creation of an issue which starts a workflow. So once she has access to this target, she will be connecting to it. So if you're familiar with Boundary, then you know how this works. We have Jane. Jane will be authenticating to Boundary. Once she's authenticated, she will click on a connect button. Well, technically, she will be using the CLI, but you can think of it as a button. And behind the scenes, unknown to Jane, there will be sort of an interaction with Vault, where Vault will be providing credentials for this session so that she will be able to sign in to this instance. These credentials will be injected into the upcoming session, and the session will be established. So, the specifics of how this connection works and the specifics of the credentials are not known to Jane. She doesn't need to know. They are just handled by the solution here. I mentioned earlier that I want to allow self-service within certain limits or with certain restrictions. So not all targets are the same. Some targets might involve, like, have access to sensitive data. They might have access to, like, be located in a sensitive network partition somewhere in your networks. So just to be able to handle these types of targets, I want to slightly modify this workflow. So here we have Jane again. She is once again going to this GitHub repository. She creates a new issue, once again specifying what she wants access to, why she needs access, and for how long. She submits the issue, but before anything is configured in Boundary, an administrator will need to approve this request. So we will see what this looks like from the administrator point of view, but once the access is approved, the workflow continues and access is configured in Boundary. All right, could I switch to the video? So here we have Jane authenticating to Boundary. And I'm using the OIDC authentication method with Enter ID in the background. So once she's connected, she will try to access a specific instance, but we'll notice that it doesn't work because she hasn't requested access to this specific instance yet. So that's the next step. She will be signing into GitHub Boundary, to GitHub Enterprise. She will go to this Boundary self-service repository. She goes to the Issues tab, and she creates a new issue. She selects between two different issue templates, and she picks the first one for Cloud Resource Access Request. She provides a title for her issue. She selects from a list of available targets. So she's interested in this Azure Linux machine. She selects a duration for how long does she require this access, and provides a motivation. So the issue is created. Now in the background there is a GitHub Actions workflow started. We can see it here. But Jane prefers to monitor the situation from the issue. So as we'll see, GitHub will notify her when access has been provided. There we go. So access has been granted. So now she can return to her Boundary client on her local machine and once again run this Boundary Connect. I'm not using transparent sessions in this, but you can imagine that it will work with transparent sessions as well. So it worked. Jane performs her testing, and once she's done, she's a responsible developer, so she goes back to her issue to close it. So she opens the issue, she scrolls down, she closes it. So now in the background, there will be another GitHub Actions workflow started. You can see it here. This workflow will revoke the access that she was granted previously. So once again, she can monitor the situation from the issue, and GitHub will inform her when access has been revoked. All right, so now let's take a look at the sensitive, how this works for our sensitive targets. So I mentioned not all targets are the same. Still the same workflow. She goes to issues, she creates a new issue, but this time she selects this other issue template for sensitive resource access request. Looks very familiar. She provides a title, she selects from a different set of targets, she selects a duration for how long she needs access, and she provides motivation for why this access. No, that's not a very good motivation, but well, all right. And now an administrator will need to approve this request because nothing will happen otherwise. So now we take on the administrator hat. And we can see that there is a notification about something going on. The administrator can open up this access request and open the associated issue. And if everything looks fine, the administrator can go ahead and approve the request. Looks okay to me. Perfect. And now it's the same thing. The GitHub Actions workflow continues performing its job. It interacts with Boundary to set up the required access. And once it's done, it will report back in the issue. So we can just make sure that it does here. Jane was able to gain access to a resource, perform her testing, and she revoked her access when she was done. All the while, the coffee was still steaming and it's still hot, so she can continue her day drinking her cup of coffee. There are a few key points I want to highlight to make this solution successful. So first of all, everything that has to do with the secure network communication, this is the domain of Boundary, right? So by strategically placing Boundary workers all throughout our networks, so in all of our cloud providers, in our local networks, whatever, we can build sort of chains of Boundary workers. And this allows us to reach any target, even in completely isolated parts of our networks, right? So you can use HCP Boundary, or you can use a self-hosted Boundary if you want to lock down access to the Boundary control plane. And for secrets management, we're adding Vault to the solution. You can use HCP Vault or self-hosted Vault. And you can use the same chain of Boundary workers in order to communicate with Vault. So there's never any need for the developer to have any access to Vault, right? And when it comes to identity management, this almost goes without saying, but you should have one single identity provider for both your GitHub environment and your Boundary environment. Because you want to make sure that an identity who requests access in GitHub is the very same identity that also gets the access in Boundary. So the interaction between GitHub and Boundary, you have a few options on how to do this. If you want, you can use HCP Terraform as the middleman. So GitHub would be creating workspaces in Terraform, in HCP Terraform, and these workspaces would set up the required resources in Boundary. Or if you want, you can use the CLI or API directly from GitHub. So both are valid solutions. They have pros and cons, but pick the one that makes sense in your environment, right? If you're familiar with issues on GitHub, you know that they are sort of just free text fields. You have a title and you have a body. And that doesn't really work in a self-service solution such as this. So to help your users submit valid access requests, you should use issue templates on GitHub. So an issue template is sort of a YAML specification of what an issue should look like. And in the GitHub UI, an issue template is rendered as an issue form like this, as we saw in the demo. And specifically for this solution, it's very important that the list of targets only include targets that actually exist in Boundary. But if you're familiar with issue templates, you know that they are just static YAML files. So how do you keep this list of targets updated? And here you have Terraform comes to the rescue. Of course, it has providers for both GitHub and Boundary. So you can make sure that whenever you're adding or removing a target in Boundary, you make sure to propagate this change to your GitHub issue templates. So onboarding new targets, this is a question about module design. And module design, I guess some of you saw the panel discussion yesterday, hosted by Ned Bellevans. So this is sort of, there is no clear answer on how to do this. It all depends on your environments, what type of targets you're adding. But you should strive to make this as simple as possible, right? So here I have a sort of a generic target module, and I'm adding a self-service flag, which I can set to true. Doing so would set up all the required resources in Boundary, as well as propagate the change into my GitHub issue templates. So we saw that Jane was a responsible developer, right? So she went back and closed her issue to revoke her own access. However, not all developers are responsible. Hands up. A few. Yeah. So we need a way to automatically clean away any access that has expired. So you have a few options for this. So I would say the easiest is to use scheduled workflows in GitHub Actions. So this allows you to periodically trigger a workflow that goes through your list of issues and closes and revokes access for any access request that has expired. However, if you were using Terraform as the middleman to set up the resources in Boundary, one very elegant solution would be to use ephemeral workspaces in HCP Terraform. So this allows you to set a specific time when resources will be destroyed. So there are pros and cons with both solutions here, but use the one that makes sense for you. So we saw that for sensitive targets, there was sort of a slight variation in this workflow. Still the same workflow, just there was a requirement to have an administrator approve the request. So how to do that in GitHub? Well, we're using environments for that. So this allows us to protect certain rules. So whenever a GitHub Actions workflow executes in the context of one of these environments, these rules will be put in place. So in the demo I had, I required an administrator to click approve, basically. There is sort of a nice side effect that just happened to come from this solution, is that the list of issues that your developers are producing, they will make up an audit log of who requested access to what, when they requested this access, for how long they had access, and why they needed access. So you can use this as a sort of starting point for further investigation and auditing if required. All right, so what have we achieved with this solution? Well, I want to go back to these 4 key characteristics that I mentioned in the beginning. We unified access management. So even no matter what type of target we're accessing, we can have a single workflow to get this access. So if it's a database in Azure, or if it's a Kubernetes cluster in your basement, or if it's a virtual machine on AWS, right? So it's the same workflow no matter what. We allowed for self-service, so Jane was able to go to this repository, create an issue following just specifying a few pieces of information, and she was provided with the access that she needed. We abstracted away the network architecture, so as you could see from the demo, there was just a boundary connect command, and then everything was handled. We have no idea exactly how complicated the way to this Azure virtual machine was. Spoiler alert, it was not that difficult in my demo, but we abstracted away secrets. And we saw this in the keynote this morning as well. We just issued this connection command, and somehow the secrets are magically taken care of for us. So they are injected into the session using Boundary and Vault. All right, now I'm a bit scared putting up a QR code because the last one didn't work. But here is a QR code. If you go to this site, it's my blog. I have a written version of this. And yeah, so I dive into a bit more details. It works perfect. Yeah, so have a read. If you have any questions, you can come and find me. And if you're interested in this study guide for the professional Terraform certification, I have the book available for free as an ebook. And that's my talk.